Hello everybody and welcome to Gregg's Vintage Workshop, where I'm working to restore history one piece at a time. Tonight we're going to be looking at part 2 of the 1937 Philco 077 signal generator. In part 1 I kind of introduced it, we took it apart, I took care of the cabinet, started replacing some bad parts, restuffing the big light caps, etc. In part 2 we're going to get through with that piece of it and hopefully get this thing up and running and put back together again. That's my hopes. We'll see how that goes. So without further ado, let's get started. So the other thing I'm happy about is these are the two pieces that were all rusty, and they turned out really nice. I just got to shoot them with some, I think I'll shoot them with some bright silver paint, and we'll have those to put back on there. So I got some new electrolytics in today to replace these 222s that they had down here. These 222s at 160 volts. I ordered a couple of 18s at 200 volts, 220 volts I think. And these will be to replace these electrolytics right here on the schematic. This one right here, going on that 6X5G, and this one up here on this side. We're getting ready to check this voltage divider right here, which is basically these two resistors, and we'll see what they check out at. The one is supposed to measure 5,000. Looking at this print here, one measures 5,000 and the other measures 9,000. So let's take a look and back out a little bit so you guys can see the meter. And we're at 4.82K. It's supposed to be 5,000 and it's 48. Pretty darn close. A little close. Now we'll have to go to this one here. This one's supposed to be 9,000, and we're at 9,300. 9,300 to 9.37K. So those are both really close. And ordinarily I would probably leave them because they're dang right on the money. But these do drift out of tolerance when they get hot, and so I'm thinking that I'm just going to probably replace them, but I'll see what I got to do that with. These are actually 2-watt resistors, and I don't think I have 2 watts, but I do have 1 watts that I can put in parallel and get where I need to be, so I might just do that. So this is my new electrolytic I got to replace these 22s down here. This is a 18 microfarad at 400 volts. I thought that was 200 is what I'd ordered, but I ordered at 400 apparently. This is a Rubicon brand, and I'm thinking about how I'm going to put these in so that the supported get. I thought about stuffing it, but that's a lot of work and I don't want to really change the originality of it. So looking at this schematic right here, this is the one. This is tied to ground obviously, and then it's tied onto the one side of the voltage divider, the 9,000 ohm resistor. So here is ground, and here is the one side of the 9,000 ohm resistor. So the smart thing to do, I think, would be to just come in here just like this. Just kind of tie this right here, and it could sit just like that. And then for the other one, we're tying into the cathodes of the 6X5 and ground, which is here, and we have the cathode. We want to tie in right here to pin 8. It's going up to the cathodes. So we want pin 8. So if we go back to the schematic, here's where we are at pin 8. So we should be able to pick up there and go to ground. And looking at this, again, where ground is here, and we've got a little wire going down to ground, which is this one right here. and 8 is this one right here on the other side of that part of the voltage divider. So I kind of something like that, and have that one laying in there flat. And of course, get some of this mess out of here. Obviously, this stuff's going to go away. Don't need these wire leads. We can clean some of these wire leads out of here and just go straight on the tube there and straight on the little terminal block there. And we'll clean some of that out. So let me see if I can get that set up. Okay, so what I'm showing you right now is I've put two 10K resistors in parallel to get my 5K, and we're at 4.95 with the two. Let's look at the old one, see which one is the better one here. Let's see, where is it? Here it is. Hopefully you guys are seeing this. The old one's reading 4.83, so the new one's closer. This old one's going to get hot and it's going to go out of tolerance. The new one shouldn't. This was a 2-watt resistor. I've got the two 1 watts in parallel. That basically gives us 2 watts, so that should be a good replacement. It's closer in tolerance. I'm going to do the same thing. Well, I've already done the same thing actually with the 9. I got two 18s together to give me my 9. I'll take a look at that. We're at 897, 899, right at 9. Let's look at the old one. This one. Nine four, 942. So although the two old ones were basically not out of tolerance at all, I'm afraid of them breaking down under heat, so that's why I wanted to go ahead and do that. So, okay, let me show you what I've been up to. So I replaced this 16 microfarad electrolytic with an 18 microfarad, 400 volts. It only need to be like 160 volts, but that was the best I could find. So I got that one replaced. I got this one replaced, same thing, 18. The voltage divider circuit, the 5000, 9000s, I replaced them with paired up 1 watts to get better than what it was showing on the originals. I added a fuse just ahead of the switch right there. Let me show you what we got here. So this is the one that ties in on the 6x5, ties in between terminal 8 and terminal 2, the positive and negative. This is the one up here, just was convenient to tie into the terminal block right here, and it's nice and clean, so everything looks nice and clean. And of course I restuffed the bakelite block there with the 2.1 caps, and then I decided to get rid of the individual wires that were feeling pretty spindly, and the actual wire leads, there's only about half of them still, you know, in there. I just used a piece of line cord that was a brand new piece of line cord. I went ahead, and this will be what jumps it, if you remember, jumps over to that plug on the actual outer chassis. I'll probably cut this a little bit shorter, but I left it longer. So that's that. And then here's the fuse, where I come from my line in over to the switch. Right there. I use one of the pigtail fuses. So that piece is done. I also drilled this rivet. I took my grinder and grinded this plate, and then I grinded the back side of the ground lug here, and I've got stainless steel. I got a stainless steel screw, stainless steel nut, and star washer under the head of the screw, star washer between the plate and the lug, and a star washer between the lug and the nut. So I think I got it good and tight, so I think that's got a good ground there. So I'm happy with that. I think it looks a lot cleaner than this mess that somebody threw in there. So this big light block right here, they had the 0.03 and the 0.05. That's going over here to the grid of the 6J5. I restuffed that. So this is it. Got a 0.033 instead of 0.03 and a 0.05 in there. So that's all stuffed and ready to go back in. That goes down here, but I'm not going to put that in until after I do the work over here on the other side. I still got all that mess to work with, but that's where we're at right now. I'm happy with that piece there. That piece is done. Okay, I'm going to test these two filter coils. I'm 35 and 38 it looks like. Could be a 36. I can't read it very well. I haven't tested those, I don't believe. I think I forgot to test those. So let's take a look at them. We're going to put them right there. We're going to put them up on the multifunction tester. I could test them with the meter, but hey, we might as well use the multifunction tester. So let's go ahead and zoom in. Let me get you closer. Okay, we're going to turn on the multifunction tester here. There we go. And see if I can get one of these coils hooked up here without boogering it up. You can see what I'm doing here. Get my terminals right. It is that one and that one, it looks like. Let's see if I can get these on here. See if I can get this on here. There's one side. I'll get the other side and then I'll turn the tester back on. Alright, I think I got them both hooked up. Says it's an inductor. It's like 42.9 ohms and 90.97 microhenries. Let's try that again. 100 millihenries, 44 ohms. Looks like. Let's try the other one. Seems like quite a high amount of ohms on that to me. But let's just see what this other one tests. If I can get everything hooked up here. I think we're on it. One millihenry, 45.4 ohms. Okay, so they're both testing basically the same. So I'm gonna say they're good. All right, well, these are testing good. Okay, I'm in the process of checking this mica cap here, which is orange, black, and red, which when I look at my color chart should be 3000 picofarad. Looking at the schematic, it's this one right here, one of the ones that switches in all the coils, and it's testing open. Right now I got it hooked up. As you can see, I've got it hooked up. If we go up and look at my meter, this is ohms right at the moment. I'm sorry, yeah, ohms. It's testing about 44,000 ohms. If I put it as diode, obviously it's out of limits on that. If I put it on capacitance, it does nothing. It just sits there and thinks about it and never does ever come back and do anything. That might be the reason why the guy put this thing for sale, even though that they had done a little bit of work to it. Probably couldn't get it to work. That cap, I think, is shot. The good news is I ordered the caps for this, two 250 picofarads and the one 3000 picofarad. It wasn't cheap either. It was $10 for the one cap for that 3000. So I guess I'll just go ahead and change the caps, the two 250s and the 3000, since I got them all, and we'll go from there. I got a few resistors I need to check as well in this mess. I need to check these caps. The yellow ones are ones that the other guy must have put in it. I got to check the solder joints, and I really need to check the caps. They're probably fine. I need to check his work and make sure he hooked them up in the right locations. Okay, so I've been in the process of going through and checking components, mainly in this section here. All of the coils seem to be checking fine. This 3000 PF capacitor is open. This capacitor here, which is a 0.05 capacitor, is open, and the lower section of this switch, which is the modulation switch, this is the on-off and modulation switch, top half being the on-off, bottom half being the modulation, is not working at all. Top portion's working, bottom portion's not. So I'm going to have to take it out and take it apart and hope that I can fix it. So that's kind of where I'm at. So I'm getting ready to pull that out of there. So let me get it out and we'll come back. So here is the on-off portion of the switch. As you can see, it's just a single throw. When we come up here, this is the modulation section of the switch. And it's normally open when the switch is in the off position. Turn on the switch and it moves to here and it connects the circuit. Turn it the opposite, continue to the other direction and it's open again. Now, when I was testing my switch, I was getting nothing doing any of these. So I took it off. I cleaned it all up really good. I didn't take it apart, but I just sprayed the living daylights out of it with my deoxit and worked it probably 100 times. And the actual on-off switch portion was working before, but I'll show you now. It's working now. It's off. There's on, and it'll stay on when it's in the other position, which it's supposed to. Alright, so now we turn it off. And these two terminals are the two terminals that are the normally open and the closed. This terminal doesn't connect to anything. It's just a stud. I can't see that it's tied to anything. I think they were using it as a tie point because it's not common with anything. But if we go ahead and connect these up, it's off, it's on, and it's off, just like the schematic. So I think it's going to be fine. I think it cleaned up good and it's all working function now. So let me get back in. Okay, so I got the oscillator transformer all pushed back together again. I actually rotated it 90 degrees. The wires were originally coming off on the side and they were kind of a stretch to make it to that other filter block, so I decided to, and the fact it was loose and falling off anyway, I decided to go ahead and rotate it around 90 degrees and put them at the bottom so they'll actually make it onto the condenser much easier without having to lengthen the wires. So now I decided I pushed it on there. It went on pretty tight because it was 90 degrees off. Even though this is a square, it wasn't absolutely perfectly square. So it's not like it's going to fall off. There's some cracks in that are made that way for you to be able to wedge it and tighten it. There wasn't nothing in there, but there was actually some wax and stuff in there, so I cleaned the wax out and I took the block over to my sander and I sanded just slightly so that it was still a press fit, and I put it in the vise and pressed it in there. So it's in there good and tight. But what I want to do now is coat it in beeswax. So I took beeswax upstairs, threw it in my microwave on high for about 6 minutes, and it did a good job of melting that. Now I'm going to set it in the beeswax, dip it in the beeswax, try and get a good coating on here. That'll help seal the wires at the top and fill all that. And don't get this on your hands because it is freaking hot. I'll dip it a couple times. Each time I dip it, it'll get a little bit thicker, but it'll also melt it. So, kind of a cross between melting it and getting a coating on there. So you just dip it in there pretty quick. If you leave it in there, it'll just melt off what you put in it. And then once I get it dipped, I've got a piece of parchment paper I'm going to set it on, and hopefully that'll be a good spot for it. It'll peel off. I think one more time should about do it. Maybe once more. I think that'll do it. I think that'll do it. I'll just set it on the parchment paper and let it finish in hardening up. I want to show you guys that. I got the beeswax from a lady local that sells local honey, and she was at a craft show, and she had blocks of beeswax, and nobody was buying them from her. I asked her what she won for them, and I don't remember what it was. It was a big bag. I mean, I think I paid her $8 for it, but I've been using it now for 3 years, restuffing capacitors with it, doing things like this, rewinding like antenna coils and then recoating them. Comes in handy. And I haven't found a better way than the microwave. I know you could put it in a pan and heat it on the stove, but this works a lot quicker, I think. And I just got myself this Pyrex container at a yard sale so that I don't have to bother my wife's, and it works great. It's glass. Okay, so we're back. I am done with the restoration of this Philco 077 signal generator. Tubes are back in place, everything's back in place. I've fired it up. I know that it all works, but I was trying to get this done quick because basically day after tomorrow I'll be on my way to North Carolina for almost 2 months. So I won't be in the workshop. I won't be able to finish the outside of this completely probably till spring. Obviously not until I get back. But I did want to show you what I got, because this is going to be the final on this signal generator, and then maybe when I get back I'll run a little quick, update showing you the final product after I shoot the clear coat on or something like that. But for now, I just want to show you where we're at. So if you look at what I've got going on right here, if I can get you situated, I bought two 250 caps, capacitors, 250 PFs. The one right here that is between the 6J5 plate and the selector switch. This one I didn't replace. I checked it and it was not bad at all. It was supposed to be 250 and it was like 270, 276, something like that. The other one, which is over here for the actual variable capacitor, this one right here, was bad. It was checking out at like right at 340. So I changed this one. I didn't change this one. I did change the big 3000 picofarad down here. The majority of the rest of the carbon comp resistors, they were fine. Even those big two were fine. I decided to change them. Be it right or be it wrong, I decided to change them, and I did change them. Now, that being said, I did put two 1 waters in there, and when I had it fired up and was doing all my checks on it, here they are down here, I touched them and they were pretty hot. So I decided when I get back in town, I'm going to go ahead and order while I'm out of town. I saw some metal oxide 5% resistors were 5 watts. So I'm going to, even that now that should be overkill, but I'm going to probably replace those with the 5 watt resistors. So I'll take care of that piece. Let me zoom in a little bit, see if I can show you a little bit of what I got down here. So the little black speck in there, right there, the shiny one, that's the 3000, and then up here, the yellow one, that's the 250. And as you can see, I didn't change any of this stuff here. Okay, so other than hooking everything back up that I'd already shown you, getting my oscillator coil back in place after I waxed it, and the other bakelite block in there that I'd showed you that had the 0.03 and the 0.05 is done. So I'm going to go ahead and put it back together again so that we can put it on the scope so you guys can take a look at it. And I almost forgot. I got that filter cap in, I got the 2 coils back in, and I used a length of new line cord to connect the 2 pieces together. I got that from Mr. Bob Anderson when he did his, and I thought it was a great idea, so I copied it. I did get the feet all cleaned up, repainted, and new felts put on it, so that's good. I did get the front all cleaned up, but it's not coated with clear yet. And it needs to be coated with clear, but it's too cold for me to coat it with clear. Okay, I don't have all the screws in. I just have a few screws to hold it together because I haven't polished the screws yet. But I did want to show you, it actually cleaned up good. I couldn't get this dial pointer indicator off, so I couldn't get that cleaned, you know, mashed out to make it look better as far as those dents, but oh well, it is what it is. It's 90 years old, so I'm fine with it. Also, I haven't epoxied this knob yet. I actually think what I'm going to do is go online and see if I can find one that somebody will sell me. So, and then I don't have to worry about repairing it. But that's that, and then I did get a handle for it. I made the handle. I made the handle from an old belt that I had. It's black, unfortunately, instead of brown, but it worked good. And I think it looks pretty good. And I used brass head screws, other than this one here. This one also held the ground post in that chassis case over there. So I used a smaller diameter screw in it, but I wanted to keep the screw heads the same. So although it's not brass, it's smaller, and I didn't want to drill the other thing out. These screw heads here, I probably will touch them up with black paint when I get back in town. The other thing I did was the cord. Get where you guys can see it. So the cord, when I was wiring this thing up, and it probably doesn't matter because this is a transformer machine, I went ahead and I made sure I knew which lead was going to be negative and which lead was positive. So what I did was I took and put a silver dot on the chassis right here, and I know that lead is the negative. So on this, which was the plug I had, I put a new polarized line cord in it, and then I used the same silver and put it on this outlet portion. So now when you plug it in, you just mate silver to silver. I got a polarized line cord, and I know that it's hooked up the way it needs to be. We're all happy with that bed lining paint that I used. I think it turned out awesome. Alright. Now, let me get you set up where we can show you what it looks like on the scope. Okay, so the first thing I'm going to show you, I don't have leads that'll fit this yet. So what I've put in here is little copper nails, the same ones I used when I built my AM transmitter breadboard here a year or two ago. So I've got those stabbed in. Right now I've got it set up with the modulation on and on audio. So we're going to check for the 400 hertz audio signal. This is on the medium. Get a good contact in there. I don't know if you guys are hearing that or not. Because I can turn this up a little bit. Put it on the high one. Medium. So that's working. I'm using the signal tracer on the MFP to show you that. Alright, so we know that's working. Now let's get it up on the scope. Okay, so I got you guys where you can see me fiddling with the Philco as well as my scope in the background over there. We're on A scale right now. You guys probably can't see what it's saying up there, but because I don't have you close enough to see that. Let's see if I can zoom in a little bit. Yeah, it's still part way we'll see it. But what I do want to show you is the attenuator is working. As I turn that, you can watch. Okay, so that's working fine. That's working great. And then, so we're on the A scale, and right now we're 121 kilohertz. And you can watch the signal as I turn this. It's about 160, 171 right there, 178. Right there it's saying 215, and on my pointer, it's saying, well, right there it says 214. My pointer is saying that should be 215, so that's not too bad, actually. And then there's 260 on that. Up there it's 262, 265. Alright, and move on up to the end here. And there is 350 right there, and it's 355 up there. Alright, so now let's go back. I'll take it to the B scale. And spread out the signal a little bit here. There we go. And we are on the B scale here. We're at 340 on this, and it shows 340 up there. So let's go ahead and just kind of close her up. And right here should be 460-ish. And we're at 461. So that's pretty dang good. And go on up. There's 700-ish, and that's 702. And there should be about 1,000 on the B scale right there, and we're at 1.002. Okay. So let's look at the C scale. Alright, so on C scale right here, this looks like this should be 1,050, and we're 1,058. And let's move on up here. Here is 1,600, and we're at 1,618 there. And going up here to 3.2-ish, and up there we're at 3.24. So that's good with the D scale. Move down to D scale. Right here would be 3.5-ish, and that's 3.52. Let's make this a little bit bigger so you guys can see it better. Let's see, we want them a little bigger. Widen that out a little bit. There we go. Alright, and let's go up to 5. Here's 5, right about there, and we're at 5.08. And move over here to 9. And we're at 9.1, 9.2. And there would be 11. Or 11.2. Okay, so now we'll go to the last scale, the E scale, and on the E scale we are at 11 right here, and it says 11.2 there. Getting some harmonics in there, and then we'll move it on up to say 14. 14.1. Move it up to, can't even read my own stuff here, 1820, this should be 20 right there. Alright, 20.29. And then come on over here, let's go to 35. 35.31. So it's working really nicely. I'm very happy with the way it's working. So my plans going forward, when I get back here, what I'm planning on doing is changing the 2 resistors, and I'll put the new 5-watt resistors in there, and they should run cool as heck. So after I do that, then I'm going to go ahead and clear coat this whole front, put my screws in after I polish them. I'll put my screws in first, then I'll clear coat the whole front, and then hopefully I'll have a knob. Anyhow, I'm real happy with this Philco signal generator. It turned out really nice. It's a shame about the dents, but I wasn't going to tear this up to try and get those out. It's had use. It's 1937, what is that, approaching 85 years old, 84 years old, somewhere in there. So it is what it is. The finish turned out wonderful. It had the cord. That turned out wonderful. I'm happy with my strap. So now I got to see if I can some shielded pin test leads for these pin type plugs on here, because I don't want to change those out. I don't want to take the originality away from it there. I want the outside appearance to look stock. So as I said, I'll be away from the workshop for almost 2 months, so I probably won't get much out. After you guys see this video, there probably won't be another video for a while, unless when I'm down there, I'm going to take my camera with me, and if something comes up I want a video, I'll do that. But I appreciate you guys sticking with me. Don't get too bored and drop me off because you don't see anything from me for a couple months. But kind of joyful. We're going down for my granddaughter's birthday. We're going down there for Christmas, and then we're going for the birth of my grandson. So that's what we're doing, and I'm lucky because I have a sister and brother-in-law that'll come here and house sit for me, and we should all be good. So all you guys have a very Merry Christmas, a wonderful holiday season, and be safe out there. So from Greg at Gregg's Vintage Workshop, thanks for watching.